All right, Unit 1, Day 1. First day of real notes in calculus. Limits. The concept of a limit is the entire backbone of calculus. We saw that a little bit on Friday. We talked a little bit about how the area would be better if you had a smaller rectangle. And the limit idea is if your width limit was 0, like if you got closer and closer to 0, then your area rectangles would be more and more accurate. And that's the whole idea of calculus, is we're going to let things go to 0. Concept opened up huge doors for great advancements. Without limits, calculus wouldn't exist, and without calculus, we wouldn't have gone to the moon. No cell phones, no microwaves, no tons of technology. So this is the very basic background of calculus, is limits. After this unit, we don't use them as much. We sort of kind of skip past them, but they're always going on in the background. Think of a limit as the intended height of a function at a certain value of x, or the intended y value. The height of a function is its y value. Like, what are we headed toward? Not necessarily what it's at, but where's it going? The limit is the intended height, the intended y value of a function at a certain x value. It's the value that the function thinks it's going to. We're trying to say the same thing 4 different ways here, or 5 different ways. It's the value that the function thinks it will attain. It might get there, it might not. We don't care. We only care what it's approaching. So approaching, intended, looks like it's headed toward, those are all the idea of a limit. Not necessarily getting there, just what are we approaching. All right, consider the function x cubed minus 3x squared. The height of the function, that's the y value of the function, changes as we go from left to right. Okay, yes. Let's look at what happens to the height as x goes towards 1 from the left of 1. So x goes towards 1. So there's x equals 1. But we want to be left of 1. So, 0.8 or 0.9 or 0.99 or 0.999999. That sure looks like y is headed toward. Y is headed to, you tell me, what is the y value headed to? As x gets closer to 1, what is the y value headed toward? -2. And then what happens as x goes towards 1 from the right? So now we want to be a little bit bigger than 1. 1.5, 1.4, 1.3, 1.2, 1.01, 1.001. We would say y is headed to, where are we headed if we're coming in from the right? Also -2. So they're headed toward the same thing. That usually happens with graphs, but occasionally you get weird graphs that have jumps where they wouldn't be the same. We'll worry about that later. Approaching an x value from the left or the right is called a one-sided limit. Right? Because you're coming from the left side or the right side, not both sides. That's from one side. The limit as x approaches 1 from the left, that little minus sign right there, means from the left. So it's not in front, that would make it -1. It looks like an exponent, but it's not an exponent, it just means from the left. And then if you wanted to be from the right, meaning you'd want to be a little bit more than 1, a little more than, as opposed to a little less than, from the right. We did this in pre-cal? Yes? Okay. Toward the end. We just said that from the left, we were approaching -2, and from the right, we were also approaching -2. If the limit from the left is equal to the limit from the right, we can say that the overall limit is the same thing, So that limit is negative 2. Okay, so why in the world do we do this? This seems kind of dumb or obvious. Well, things get a little more interesting when our functions get a little more interesting. Consider that guy. Pre-cal review experts here. Why does that graph have a hole in it? Do you remember? Why is that hole there? If we factor it, so we take out an x squared, and we cancel the x minus 2's, but x can't be 2 because that would make the bottom 0. That's why there's a hole there. Okay, limit as x approaches 2 from the left. So we're a little bit less than 2. 2 minus, that's, I mean, the symbol's supposed to make sense, right? 2 minus means a little less than 2. So we're coming up upon 2 from the left. What's the y value approaching? 4. Yeah, it doesn't matter if there's a hole there, because we don't care what happens when we're there. We're approaching 4. And then from the right, well, we're approaching 4 again. Some questions are easy. Are they the same value? Yes. Therefore, the limit as x approaches 2 is 4. If the left limit equals the right limit, then that's the overall limit. And we do not care what the actual value of the function is at x equals 2. We don't care if the function even exists at x equals 2. In fact, this one doesn't exist at x equals 2. But limit doesn't care about function value. It cares about what are we getting close to. Okay, well now we got a weirder function, a piecewise function that's got a jump in there. Limit as x approaches 2 from the left. So coming from the left, so there's 2. I want to be a little less than 2. What are we approaching? 4. And if we come from the right, so we're at 2.1 and 2.01 and 2.001. We're approaching 5. And the open circle, closed circle stuff doesn't matter because we don't get there. We're just approaching. Which means, do you remember? Oh, there's the answer right there. If the two limits are different, then the overall limit just doesn't exist. They've got to go to the same thing for the limit to exist. And we can abbreviate that with dNE. On the next set of questions, I would say they're kind of grouped like that. 4, 4, 4, and 2. Because it goes left limit, right limit, overall limit, and then the function value. Let's do the first one together, and then I'll pause and let you do the rest. So limit as x approaches 1 from the left. You know what? Let's jump in with that. Jimmy, first one. Limit as x approaches 1 from the left. What would that be? 7. Very nice. Abby, as x approaches 1 from the right? 7. Brooke, you really don't even need the picture. If the limit from the left equals the limit from the right, then what's the overall limit? 7. Addie, you get the trick question. G of 1 is 2. Very nice. So now we're talking at x equals 1, not approaching anything, but actually at 1, we're right there at y equals 2. Alright, I think this is old news, so I'm going to press pause, and you guys see if you can finish those. Okay, 10 more questions. So you're checking those if you need to check and see where you got if you're watching the video. Next page. Limits of infinity, limits at infinity. Different things. Of infinity means the y is headed to infinity. Limits at infinity means the x is headed to infinity. All right, consider that graph. So there's an asymptote at x equals 2, because x can't be 2. That would make the bottom be a problem. Again, I'm not even reading the questions yet. I'm just seeing if I can make sense of this graph with that equation. Okay, as x increases without bound, what is the height the function is increasing? So that means as x approaches infinity, so x is going way, way, way out here somewhere, like way off the chart. What is the y value approaching? That's kind of a tricky one. Where'd you get 0.5 from? You're right.
Because the other one goes above.
Okay, so you looked at the other side, and you're like, well, I don't think it's 0 because this one's up here. That's right. I haven't really done this yet, but the ratio of the coefficients, you do that in pre-cal? I get confused when I teach pre-cal and calculus. So that ratio is 1/2. We're headed toward 1/2. Powers are the same. Exponents are the same. Divide the coefficients. This is called a limit at infinity because x is going to infinity. You really don't need to, I mean, you need to know that, but it's not like I'm ever going to explicitly test of versus at. If a limit as x goes to infinity is a real number, not infinity, then you have a horizontal asymptote. So what we just discovered was something you kind of already knew, but there's a link there between limits and asymptotes. There's a horizontal asymptote of y equals 1/2. Question: can a function cross a horizontal asymptote? Well, this is where sometimes your math teachers lead you astray. Yes, you can cross a horizontal asymptote. You can't cross a vertical asymptote because vertical asymptotes happen where you're dividing by 0, and you definitely can't do that. So you can't cross a vertical asymptote, but you can cross a horizontal asymptote. And that definitely throws people off because you probably had a math teacher that said, don't cross an asymptote, and they weren't being specific about what kind of asymptote. All right, this looks really technical, these next two lines, but if we slow down, as x goes to infinity, if the limit is approaching L, then y equals L is the horizontal asymptote. And same thing on the other end, as x goes to negative infinity, if the limit is k, then there's a horizontal asymptote at k. Sometimes L and k are the same thing. Like a lot of times for us, they're the same. Like the left end is approaching 1/2, the right end is approaching 1/2. But it doesn't have to be that way. You could have a weird function that has one limit on one side and another limit on the other side, something like that. So be careful. It doesn't mean, in that case, there's two horizontal asymptotes. All right, let's look at this next picture. Again, before I even look at anything, vertical asymptote at x equals 4, that makes sense. All right, now let's answer these questions. As x approaches 4 from the left, x approaches 4 from the left. What's happening? What's our y value headed toward as x approaches 4 from the left? Negative infinity. And what about 4 from the right? Positive infinity. And therefore the limit as x approaches 4 doesn't exist. They're going to different places. When a limit from the left or the right approaches infinity, we have a vertical asymptote because we're headed up to infinity. This is called a limit of infinity. If a limit is equal to infinity, then that limit does not exist. Okay, you might remember this is a little bit tricky because it's like, well, which answer do you want? Is it negative infinity or D and E? And Answer is yes, that's right. It's both of those things. Usually this would be a multiple choice type question, and we would not put both of those in your choices because they would both be right. So either if D and E is there, that's right. If negative infinity is there, that's right. You could answer either way. And if it's a free response, I would probably rather negative infinity because that's a little more specific. But I wouldn't mark off for D and E because it's correct. Oh, answered this already. Can a function cross a vertical asymptote? Definitely not. Because that would be dividing by 0. That's why there's a vertical asymptote there. Again, here's some technical language to try to say what we already said. If x approaches a from the left is going to positive or negative infinity, then there's a vertical asymptote. Whether it's from the left or the right. Left or right. Okay, we've already said everything in these 6 statements, but we're trying to just restate it to summarize what we've already done. Every one-sided limit exists unless the limit is infinity or negative infinity. For a regular limit, meaning not one-sided, if there's a hole, the limit exists, and it's the y value of the hole. So this was we saw an example where something like that happened. You can have a limit at a hole because we don't care what's happening at the point. We care what's happening as we get closer to the point. For a regular limit, not one-sided, if there's a break in the graph but not a hole, the limit does not exist. May as well put the fancy term on that, if there's a jump. If there's a jump in the graph, then there's no limit. There might be a left limit and a right limit, but there's not an overall limit. Let's see, the limit is x approaches infinity or negative infinity. So that would be going way out to the right or to the left. Right or left. Then you have a horizontal asymptote, if that limit exists. If your answer is infinity, if you get a limit of infinity, like a y value of infinity, then you've got a vertical asymptote. And again, there's this technical thing of if you put positive or negative infinity, that's okay, but technically that does not exist. All right, here's a whole bunch of practice problems with a really weird-looking graph, but forces you to think through some things here. So let's do the first 4 together, and then I'll leave you alone to work some. I say together, I'm still going to pick on some people here. So I got your name by the one I'm going to ask you about, McKenna. Number 1 is x approaches negative 6 from the left. Negative 6 from the left. McKenna, what's that limit equal to? Yes. Holly, how about negative 6 from the right? Also 2. So Avery, that means the limit as x approaches negative 6 is 2. And James, what's the function at negative 6? 2. This is something that we'll discuss on Friday. Basically, if all of these are the same, there's a special word for that. You know what that word is? Did we do that last year? We'll come back to it later. Continuity. If they're all the same number, then that thing is continuous, as opposed to these other examples. So why don't you try those next 12 examples. Resume, so if you're watching at home, you can check those answers. And then today's assignment, which I'll pass out, get the packet, but today's assignment is worksheet 1. We still have 17 minutes, so you might finish this, because we've done these before. They go pretty quick, and once you get the hang of it, you're okay. Question? Uh-oh. -8 from the right. So I'm a little bit bigger than -8. I'm going up, up, up. I'm headed toward positive infinity. Got it? It's okay. But thank you for asking. Good questions. All right. Again, answers are posted. Videos posted.